Let's talk about problem 1 from constant velocity, problem set 1, because there's a lot of richness in here that your first time solving, it's really important you understand these details that I'm about to talk about. So for problem 1, let's talk motion map first. I've presented two versions of a motion map. One is more detailed on left than the other on the right. Now, depending on the instructions you're given, either motion map could be the right way. In this case, I've specifically asked you to sketch a motion map. Sketch is a looser command than plot, so it's okay to leave off some details. Oftentimes those details are exact position, locations like you see here in the one on the left. You can drop those. Things I do want to see. I definitely want to see the direction of travel, so arrows that point either left or right. I'd like you to label the velocity. Make an attempt at getting the arrows the same length, suggesting that for every second that goes by, the object travels the same distance. The length of the arrow is related to velocity. And also mark for me the initial position. So again, that's 3 details I want you to show on the motion map. The one in the box here, that is a sketched motion map. This one's a little more plotted. In this case, the motion maps aren't terribly different. I'll buy that, I understand. But let's look at the position versus time graph. I think there's a little more difference here, and newbies kind of struggle to discern this difference. So again, I want you to sketch the position versus time graph. On the first one, I've made use of the grid lines on my paper, and I've marked positions 0, 2, 4. I've counted out grid lines. I've taken care, math class style, to make everything nice and neat and orderly. I've done the same thing with the time axis. I've even plotted points on this line. That's a plotted graph. Over here, I've sketched the graph. What's important to show in a sketched graph is the general trend, i.e. the slope. Is it positive or is it negative? And if you're comparing two motions, I need them to be relatively accurate. In this case, there's no comparison, so I've just got a line with a positive slope. I have labeled the axes, but because it's a sketch, units aren't really required. Really what I want to see on a graph sketch is a general trend. Oh, one other detail. In addition to the trend, I also want to see the initial value. So in this case, like a y-intercept, right? An initial value. 2 things to show on a position time graph. You got that? Let's move on now to the algebraic relationship. There are 2 algebraic relationships here. Unlike the other 2 examples where it's like a more detail, less detail, this is more about how you name the variables. If you were in a math class, it would be totally reasonable to take that graph or this graph and do y equals 2x, right? Where 2 is that speed that was given to you originally in the problem. That would be the math class answer. This would be the physics class answer. Note the biggest difference is that I have renamed the variables to match physics variables. Down here, optionally, I've written this out. This is something in brackets here that we'll just all understand as we get going along. I think the biggest thing that really messes with people is the x variable here, referring to the horizontal quantity, is not the same as the x quantity here, referring to the variable called position. I'm sorry about that. Like right now, I'm just going to say, I'm sorry, this x and this x are not the same thing. Very different stuff. Please use physics variables when writing algebraic relationships.